Welcome back to Civic Innovation, where we explore how to leverage and use generative AIs in ways that make us more productive, more efficient in the right things within local government. So last week, I wrote a Substack article on the different visualization tools that Chat GPT and tools like Julius AI and things like that, the different tools that they allow us to do, right? The different ways we can analyze data, visualize it, and how powerful that is. And I also said in that article, which if you go to Substack, just search for my name on Substack, that's going to show you, you'll see the article there, all the visualizations that we never thought of. So, welcome back to another video here with Civic Innovation, the YouTube channel dedicated to discussing and showing us how to leverage ChatGPT, generative AI, Julius, Perplexity, all the different tools, how we can leverage that for local government in ways that makes a meaningful difference. Last week, I wrote a Substack article on the different visualization and data analysis tools that are out there, things like ChatGPT Plus, the tool Julius. And in the article, I mentioned that this probably needs to be a video, and so here we have it. Here's the video. So I want to walk you all through how to do this. Now, the data I'm using is from data.gov. It's an open source. Anyone can go on there, bunch of open source data on there. So what we're going to do is we're going to pull in some data and have ChatGPT analyze it, and then we'll also do a second video, so stay tuned for that. I'll post a link for it right here. We'll do a second video doing kind of the same thing, same data set in terms of from data.gov, but different data just for variety's sake. We'll do the same thing in Julius as well, that we can see it as well too, so see it in action. So let's go ahead and get started here. What we're going to do is we're going to say, I have some data from Cary, North Carolina that I want you to analyze from the perspective of an economic development director. Okay, perfect. So now I'm going to go ahead and upload this data. Okay, here's the data. It's in a CSV file. And for this one, the data is pretty massive. So while it's up, I want to show you where this data comes from that you can kind of see it, right? So here's the data that I got from data.gov, real estate data. And it's focusing, I guess, looks like Cary might go into Wake, Durham, and Chatham counties. And so what I did for this is I just focused on Wake County for simplicity's sake. And we downloaded the whole data set here, all the different apartments and real estate information here. Let's go back here and let's give it to say, here is the data set. So it's going to load the data and see what it contains and discuss how to proceed with analysis. Let's take a look. All right, here we go. Got some information here. All right, so it's going to give me some ideas on terms of what I might be interested in as an economic development director. So we can talk about identify trends in property development over time, assess land use patterns, evaluate the distribution of commercial versus residential properties, analyze property values and their growth against different parts of Cary. And so let's try one here. Let's try identify trends in property development over time. And again, I can click this quotation mark there and just click here, or let's click let's do this. Okay, I'm going to focus on the year built, the calculated average, the location zip code, and so we can find some stuff there. It's going to prepare the analysis now. All right, so here it just gave me the visualization right away, which is just so cool how we can do that, right? So it's going to give us some observations in terms of number of properties built, the average acreage per property also varied. Let's go ahead and take a look at this chart here. So we have property development trends over time beginning from 1825 all the way through here. Obviously a little spike there. And let's go like this. Let's go ahead and focus in on the last 5 years. Let's say I want to focus on the last 5 years. Okay, so here we have it. Now here we have the last 5 years, right? 2018 all the way through 2024. You can see it's giving me the average acre, which I think is important, and then the number of properties built as well too. You can see those trend lines go there. So pretty cool how quickly we can do this, right? We can pull this data in and look at the different visualizations, right? So let's go ahead and do another one. We talked here about real estate. Let's do another example. So I'm going to close this off. And let's now look at, instead of fire hydrants, let's go over to solar permits, right? Still the city of Cary, North Carolina, but let's look at some solar permits here. Again, I'm going to download this data set. Here we go. And let's say now I want to bring in solar permit data. Okay, go ahead and grab this solar permit application data here. You can tell it's not quite as big of a file as our real estate data was. Let's go ahead and bring this in and see what we can find. Okay, so here's our solar permit data, and we see here it's going to try to merge the data sets based on property addresses or other relevant fact identifiers. You could also analyze the trend of solar permit issuance over the past 5 years, examine the relationship between property developments and solar installations. Let's try this. Let's just see if this works. I don't know if this is going to work, but let's try it out. Let's try this. Okay, it's going to prepare both data sets for merging, clean and format the addresses, filter the solar permit data, and try to merge the data sets based on the common address fields. Okay. No way. So I want to take a quick moment because I am literally speechless right now. I want to take a quick moment to recognize what just happened. For those of you who understand working with data sets and what it means to merge data sets based on addresses specifically, like that specifically, this is a monument. I don't even know. I wanted to show a video on how to build visualizations, what that looks like, how to, and how to build it out, how to bring in large data sets and things like that. I didn't even know we can merge data sets together. That's incredible. Wow. I'm speechless, y'all. I'm speechless right now. Like I've got nothing. I feel like I just quit the video right now, and this is going to be valuable because the fact that we can merge data sets based on common fields and how fast I did it too. Right? Like we know how to merge data sets. We've done it before. Those of us in the data field understand how to do that. We look for it, validation. And obviously, I want to make sure if I'm actually doing something more serious with it, other than creating a YouTube video, I'd want to do some verification to make sure it's really validating along the right lines. But just the fact that it was like, oh, I can merge those two databases together. Why not? In about like 10 seconds or whatever it was. That's incredible. Wow. I'm sorry. Sorry to nerd out on y'all right there for a quick second here. So let's go ahead. Let's see the number. Here's what we can do now, right? So back to the show. Here's what we can do. We can determine the number of properties with new solar installations. We can compare areas with high solar permit issuance to general property development trends, or assess the impact of solar installations on property values and other development metrics if such data is available. Let's try this. I'm not sure if this is going to be available, but let's go ahead and try. Let's try this. Okay. It's going to look at comparing property values of installations with solar permits versus those without. It's going to analyze any notable changes in property development metrics like acreage or property type associated with solar installations. Let's see if we can get lucky. Maybe we'll get 2 for 2 in this one. If not, we'll go back and find something different, but hopefully we get lucky. Okay, the data set includes a variety of fields, but to assess the impact of solar installations specifically on property values and related metrics, we should focus on property values related fields, year built, other metrics, such as location, acreage, and potentially other descriptive fields about the property. Since property value data appears to be missing, we can start by comparing acreage and year built between properties with and without solar installations. This can give us insight into whether properties with solar installations tend to be newer, larger, or located in specific parts of Cary. Okay, so here we go. Year built. Properties with solar installations have an average build year of approximately 2006. Calculated acreage. Properties with solar installations, about 0.269 without 0.227 acres. Some insights here. And let's see if we can build a kind of visualization and begin focus on the last 5 years of data. Let's again focus on the last 5 years of data. What can you visualize? Or let's just say, please visualize these insights. So looking at possibly doing a histogram of some sort. All right, so here we have 2 side-by-side charts, right? We have one with the distribution of property construction years and then distribution of property acreage. So you can see that here. Let me try to scroll a little bit so we can see it a little better on the screen. I'll zoom in so we can kind of take a look at this now. So here we have the distribution of property construction years, year built with solar, without solar, and then with solar, without solar in terms of the acreage there. But again, the histogram is kind of a cool way to visualize something, right? Again, to me right now, as I show this video, I'm not worried about the accuracy of the visualization. I know that sounds terrible to say, but I'm not, right? I want to show you what these visualizations look like, how to build it, or what that does. And so obviously, if I'm looking for more accuracy, I would tell the GPT, hey, that doesn't look right. So let's actually try this. Because I suppose it does look right, just overlaid right here. Yeah, that looks probably fine. Makes sense to be more homes built or distribution of property construction. Like new construction is not necessarily going to have solar on it right away. So yeah, that makes sense. Yeah, makes sense. So I'm still going back and tripping over the fact that we were able to merge data sets together. I don't know if I'm going to be able to get over that. It's going to take me a little bit. I'm going to have to sleep on it tonight and think about that, because that is pretty cool that we can merge data sets. But I hope you enjoyed this. This is how you can build different visualizations, how you can bring data in. CSV is a great way to do that. And just give it the role, tell it what you want to do, try things, right? We tried something new, and that's what we want to do with Chat GPT. That's what you need to do with these generative AI tools. Don't get stuck in the old ways of, I got to do this prompt this way or this thing this way. No, just talk to it like a human being, try different things, and just see what happens. It's amazing what happens when you test the limits. We try to push it beyond what you think is capable. You walk away amazed at what it can do.